An incidence matrix is a matrix that shows relationship between the two class of the objects. This here we are showing the relation between the two parameters. Is it right? This is known as the incidence matrix. Here it is. The incidence matrix in a graph theory shows relation between the node and the branches. Because everything will be expressed in terms of the matrix in this particular chapter. So first we will try to show the relation between the nodes and the branches by the matrix from the graph, and that matrix is known as the incidence matrix. Is it right? The incidence matrix is the graph. Incidence matrix in a graph theory shows the relation between the node and the branches. How it is, that I will discuss here. First, I will discuss the procedure for drawing the incidence matrix. How to draw the incidence matrix, that procedure I will discuss first. In this matrix, the nodes are the rows of the matrix and branches are the column of the matrix. Suppose any graph consists of the 4 nodes, means that matrix 4 nodes, then that matrix should consist of the 4 rows, 1, 2, 3 and 4 rows. Here A, B, C and D, these are the rows of the matrix. And if that graph consists of the 8 branches, that this is column number 1, column number 2, column number 3, column number 4, column number 5, column number 6, column number 7 and column number 8. Means here is one element, here may be the one element, here is second element, third, fourth, fifth, sixth, seventh and 8. This is related to the node A. Are you getting me? Means in this matrix, in this incidence matrix, rows of the matrix are the nodes, and the columns of the matrix are the branches in the graph or in the figure. Is it right? Now look at the procedure for construction. If the branch is connected to the node and its orientation is away from the node, this is the node and this is the branch. If its direction or orientation is away from the node, if I am talking about this node, if it is away from the node, then corresponding entry in the matrix is taken as a +1. Then its entry will be +1 in the matrix. Is it right? If it is away from the node. If any branch is connected to the node and its orientation is towards the node, then that entry is taken as -1 in the matrix. Then that entry will be -1. Means same branch for this node, for A node, suppose here is the A node and suppose here is the B node. The same entry for this node will be +1 because it is outgoing, and for this node it is incoming, that's why its entry will be -1. Outgoing current is taken as a +1, incoming current taken as a -1. And there is no such standardization in the previous method which we have discussed. Node analysis में ऐसा standardization नहीं है, but we want to use this data to the computer for the calculation. That's why we have to standardize something. What is the standardization here? Outgoing current for that particular node is taken as a -1 and incoming, +1, and incoming current is taken as a -1 for that particular branch, and we are able to find out the relation between the nodes and the branches. Finally, the last point, if that branch is not connected to the node, then corresponding entry will be taken as 0 in the matrix. सिर्फ इस मैट्रिक्स में 3 एंट्री आ सकती है for corresponding node and corresponding branch. Entry may be +1, entry may be -1, or entry may be 0. In the matrix, we have to enter one of the 3 values, +1, -1, or 0. If that current of that particular branch is leaving the node, then that entry will be +1. If that current is entering into that node, then it is -1. If that branch is not connected to that node, then its entry will be 0. I will show one example, then I will discuss, and then I will come back to you. Yeah, this is. Now, how many nodes we have for this figure? This is node number 1, this is node number 2, this is node number 3, and this is the node number 4. We have the 4 nodes. Means in this case also, we should have, four rows, because we have 4 nodes, 1, 2, 3, 4. This may be the row related to the row node A. This is the second row related to the node B, maybe. This is related to the node C, and this is related to the node D. This is row number 1, row number 2, row number 3, row number 4. And in this matrix, always we have the number of columns should be same as the number of branches of this graph. We have 1, 2, 3, 4, 5, 6. 6 branches. It just should be the 6 columns. This is column number 1, column number 2, column number 3, column number 4, column number 5, and column number 6. Means we have 4 nodes, means 4 rows, and 6 columns. That is nothing but the 6 branches. Then look at how we are making the entries. Look at here. This is the node A. I am writing first for the node A. For node A, this 1 is incoming. This is -1. This 5 is outgoing. This is +1. The 6 is outgoing. This is +1. Because in my matrix, this is branch number 1, this is the branch number 2, this is the branch number 3, this is the branch number 4, this is the branch number 5, and this is the branch number 6. Now look at this 1 is incoming, -1. This 5 is outgoing. 5 is outgoing. For this 5, it is a +1. This 6 is outgoing, +1. And other than these 3 branches, no branch is connected to the node A. That's why the remaining entries will be 0. Are you getting me? Similarly, if I'm coming to the node B, look at here, this node B. For this node B, branch number 2 is incoming. Branch number 2 is -1. Branch number 5 is incoming. It is -1. Branch number 4 is outgoing. Branch number 4 is outgoing. Look at this is +1. Branch number 4 is a +. And remaining branches are not connected to the node. That's why 0, 0, and 0. Are you getting me? Because everything we want to show or we want to draw in terms of the matrix. That's why there is importance of this incidence matrix. If I'm coming to the node C, look at the node C. Branch number 3 incoming. Branch number 3 -1. Branch number 4 incoming -1. Branch number 6 it is incoming, which is -1. Is it right? And remaining branches are not connected to the node. That's why its entries will be 0 in the matrix. And finally, if I am coming to the node D, this node, which is the D node, in this particular case, look at this is outgoing, outgoing, outgoing. 1, 2, 3 outgoing. This 1 is a plus, 2 is the plus, 3 is the plus, because outgoing current is taken as a plus, and remaining branches are not connected to the node. That's why its entry will be 0, and this matrix is known as the incidence matrix. Is it right? It is simple. And this matrix has a lot of importance in the calculation. Believe me, I will discuss later on. I'm trying to discuss the things one by one. I will come back to this figure which I have considered. This figure which I have considered here. And then I will take the questions from your side. Is it right? This is one given circuit. For this circuit, we want to obtain the incidence matrix. How will be the procedure? Generally, such problems are asked in the examination. For this given network, draw the incidence matrix. It is for 5 to 6 marks. How is the procedure? Look at it. First, we have to mark the nodes. Right now, we are not interested in the values of the branches and the values of the sources. This is the one node, A node. This is the second node, that is node B. This is the third node, that is node C. This is the fourth node, that is node D. And this is the fifth node, that is node E. For this particular figure, we have 5 nodes. First, I will draw its graph. Is it right? This is node A. This is node A. This is node B. This is node C. This is node D. And here is the node E. We can draw the oriented graph also. If I'm interested in the drawing the oriented graph. How will be the oriented graph? This is the branch number 1. I will name it as branch number 1. It is forward. This is voltage source, can be replaced by 0 resistance. This is downward, which is the branch number 2. This is again downward, which is the branch number 3. This may be the backward. This is the branch number 4. This may be the branch number 5. This may be the branch number 6. This may be the branch number 7. This may be the branch number 8. This is the 7. This is the branch number 8. This is the branch number 1, 1, 2, 3. This is 4, 5, 6, 7 and 8. You can give any random names to the branches if it is not given in the figure. You can give any names randomly to the nodes, and you can assume any random direction as per your convenience. Is it right? Now I will draw the graph for this case. How will be the graph? Now look at its graph. This is the branch number 1. This voltage source can be replaced by the internal resistance. This is one part. This is second part. This is third. This is fourth. This is fifth. This is sixth. This may be the seventh, and this may be the eighth. This is the graph. Now I will count the branches. This is upward, branch number 1. This is downward, branch number 2. This is downward, branch number 3. This is backward, which is branch number 4. This is backward again, sorry, downward. This is branch number 5. This is downward, which is branch number 6. This is forward, which is branch number 8. And this is downward, which is the branch number 7. Is it right? And this is the oriented graph or directed graph. Is it right? I'm interested in finding its incidence matrix. I have not started the discussion of the matrix yet. I am discussing about how will be its graph, how will be its oriented graph. Now I will discuss how will be its one of the tree. कोई एक tree इसका मैं discuss करता हूँ. I will discuss its tree. How will be its tree? Suppose this is one branch, second node, third node, and this is the fourth and fifth. This node is the node A. This is the node maybe B. This is the node C. This is the node D, and finally it is the node E. These are the nodes first I have drawn, and I am planning to draw the tree. How will be the tree? Tree is the set of the branches which connects all the nodes to each other directly or indirectly without forming a loop. And how many number of tree branches we have? Number of tree branches is equal to n minus 1. Number of tree branches is equal to, I will call it as BT. There is number of tree branches, BT is equal to n minus 1. How many nodes we have? There is 1, 2, 3, 4, 5. It is same as 5 minus 1, which is nothing but the 4. Which our tree should have the 4 branches. How it will be? This is 1, this is second, this is third, and this is the fourth. Now in this case, all the nodes are connected to each other directly or indirectly without the forming a loop. Now this is the tree, one of the tree. This is the branch number 8. This is the branch number 4. This is the branch number 2, and this is the branch number 6. It is the tree, one of the tree of this graph. There may be the possible number of the trees, और भी trees हो सकते हैं. I will show one example here. Other possible ways of the trees or some another tree. Here, if I am drawing something like this, this is also one tree. This is also one tree, because this is node A, this is node B, this is node C, this is node D, and it is the node E. In this case, all the nodes are connected to each other directly or indirectly forming the loop. That's why this is also the tree. It is one tree, this is another tree. There may be the n number of the trees are possible. Is it right? Then, how will be its co-tree? For this tree, if I am drawing its co-tree, this is node 1, this is 2, this is 3, this is 4, and this is 5. The names are same. This is A, this is B, it may be C, this is D, and finally it is E. In that case, how will be its co-tree? 1, 2, 3, 4. I will exclude those branches and I will draw the figure. This is 1, this is second, this may be the third, and this is the fourth. This is the branch number 1, this is the branch number 3, this is the branch number 5, and this is the branch number 7. And this is the co-tree for this tree. This is the co-tree for this tree. And for this particular tree, there is again code tree. How will be its code tree? I will draw by the red lines. Here, this is one branch, second branch, this is the third branch, and this is the fourth branch. Means nodes with 1, 2, 3, and 4 branches. Whatever we have, this whatever I have shown by the red color and the dotted line, that is the code tree for this selected tree. We can show its orientations also. This is the part which we have already discussed and understood. Is it right? Right now, I am not interested in this part. I am interested in drawing of the incidence matrix. Now, I will come back to the incidence matrix. Look at here. How will be its incidence matrix? It is indicated by the letter A. A is the standard indication of the incidence matrix. Now, how is this matrix? The number of rows in this matrix is same as the number of nodes. Here we have the A node, we have the B node, we have the C node, we have the D node, and we have the E node. That's why 1, 2, 3, 4, 5 rows will be there. How many columns will be there? We have how many branches? We have the 8 branches. It's column number 1, column number 2, column number 3, column number 4, column number 5, column number 6, and column number 7, and column number 8. Is in this particular case, or for this particular matrix, we have the 8 columns. We have the 8 columns and 5 rows. 8 columns and 5 rows. I will make something this line. These are the rows. And this is column. This is column. I'm drawing this because we should be able to draw the each and every element. We should not get disturbed. That's why I'm drawing this. Now look at it. I'm discussing about this node A. For this node A, branch number 1 is outgoing, this is outgoing, this is out 1, 8, 7. 1 is outgoing. How will be the outgoing entry? Outgoing entry will be taken as +1. 1 is the +1. 8 is also +1. Then 7 is also +1. Other than that, there is no other branch connected to this node. That's why remaining entries will be 0. These are the entries which are 0. We have completed the node A. Then I will start with the node B. If I am starting with the node B, 8 is incoming. That's why it is -1. This 2 is incoming. It is -1. This 4 is incoming. It is -1. And then 6 is outgoing. 6 is outgoing, that is +1. And remaining entries will be 0 for that particular node. If I am coming to the node C, branch number 5 and 4 are the outgoing. Branch number 5 and 4 are the outgoing. That's why I will write it as a +1. 4 and 5. Branch number 3 is incoming. That's why I will write it as a -1. And remaining branch entries will be 0. That is the formation of the incidence matrix. Similarly, if I'm coming to the node D, look at for the node D, branch number 1 is incoming. That's why it will be -1. Branch number 2 and 3. 2 and 3 are outgoing is +1 and +1. And remaining branches are not connected to this particular node. That's why its entry will be 0. Its entry will be 0. And finally, if I am coming to this node, that is E node, in that case 7, 6 and 5 are incoming. 7 is incoming, -1. 6 is also incoming, -1. 5 is also incoming, which is -1. And remaining entries will be 0. Remaining entries will be 0. And this matrix is nothing but the incidence matrix. Nothing difficult. Though it looks to be complicated, we have to draw this, we have to draw this, and from this we have to draw this. If you are not understood this, then formation of this matrix is difficult. But from the understanding, if you want to bug up this and if you want to copy this from someone, then there is obviously chances of the error. But if you have understood this, then drawing of the incidence matrix is not the complicated way. This is the way to draw the incidence matrix. And there is one property of the incidence matrix. I will discuss in the property also, but here I will show that. The addition of each column is always 0. Look at it. +1, -1, addition is 0. -1 + 1, addition is 0. -1 + 1, addition is 0. -1 + 1, addition is 0. This is +1 - 1, addition is 0. +1 - 1, addition is 0. Is it right? Then here plus 1 minus 1 addition is 0. This is plus 1 minus 1 addition is 0. This is the property of the incidence matrix. Summation of each column is always 0 because that we are finding for the branch. How much is the current in the branch? Look at here. Whatever the current, it is incoming, it is outgoing. That's why how much is the current remaining with the branch? 0. That's why this is outgoing and this is incoming. Its incoming current is equal to outgoing current. That kind of the approach will be there. That's why this column-wise summation of the each branch will give 0 value. That is nothing but summation. This is one of the property. I will come back to you and I will discuss this property and we will discuss the similar things about this particular method. Now look at this. This is the incidence matrix which I have discussed there. Look at the properties of the incidence matrix. Look at the first property. The sum of the elements in any column is always 0. Sum of the elements in any column is always 0. Look at this part. Here, in this case also, this is minus 1, plus 1, 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 plus 1, minus 1. Its summation is always 0. Column-wise addition. Column-wise addition is always 0 in this particular case, which is nothing but one of the property of this matrix, which is sum of the element in any column is always 0. The determinant of the complete incidence matrix is always 0. Its determinant is always 0. The rank of the incidence matrix is n minus 1. Its rank of this particular matrix is n minus 1. These are the properties of the matrices already you have discussed in mathematics. Is it right? That's it about this incidence matrix. Now I will discuss the reduced incidence matrix. But before going to the reduced incidence matrix, I'm expecting some feedback from your side. I will come back to you. Yes, one by one. Akash.
Yes.
Akash.
Yes.
Are you there? Any difficulty in the formation of the incidence matrix for the given period?
No, sir.
Chinmay.
Yes, sir.
Any difficulty in the formation of this incidence matrix?
No, sir.
No. Chaya. Any difficulty?
No, sir.
No. Then Rishikesh.
Yes, sir.
Any difficulty in the formation of the incidence matrix?
No, sir. No difficulty.
No difficulty. Ruchira.
No, sir. No difficulty.
Saurabh.
No, sir. No difficulty.
No difficulty. Then Tanveer. No difficulty. Okay, fine. So sometimes what happens, if we have given with this part, if we are given with this part, which is nothing but incidence matrix, then we can draw its graph. Is it right? That terminology is also there. I will discuss that kind of the problem. But before that, I will discuss first the reduced incidence matrix, because sometimes if it is given to you, incidence matrix is given to you and it is asked that draw its graph, we can draw. Suppose in that graph, this may not be given to you, A, B, C, D, number of nodes may not be given to you, and this number of branches will not be given to you. This part will not be given to you. Is it right? So here you can count 1, 2, 3, 4, 5. We have the 5 rows, means we have 5 nodes. I can put the 5 nodes 1, 2, 3, 4, 5. 5 nodes. Fine. Then count the number of columns 1, 2, 3, 4, 5, 6, 7, 8. We have the 8 columns. Means we have the 8 branches. Is it right? Then we can connect this A and D. For A it is a +1 and D it is -1. This branch number 1 is connected between A and D. For this branch number 2 it is connected between B and D, and its direction is from plus means D node towards the B node, because incoming B may have, because it is -1. Branch number 3 is connected between C and D. Branch number 4 is connected between the B and C. I will show. This branch number 4, branch number 4 here, it is connected between the B and C. Now look at how is this orientation. Its orientation is from the C node to the B node. C node to the B node. Means if the incidence matrix is given to you, we can draw its graph. Our graph is given to us, then we can draw this matrix also, which is nothing but the incidence matrix. Is it right? That is about this incidence matrix. I will come back to you and I will discuss about the new point in this case, which is thus reduced incidence matrix. Reduced incidence matrix. Recall the things which we have studied in the nodal analysis method. This is concept similar to the nodal. I will discuss when I will go to the Tyset and Kepsis. This is right. Generally, we are considering only the required nodes. In this case, if we have nodal analysis, 1, 2, 3, and 4 nodes. How we will do generally? Generally, we will choose one of the node as a reference node or ground node or bottom node. Suppose I have taken this node as a reference node. Then delete the entry of this node and whatever the incidence matrix we have, that is known as the reduced incidence matrix. Are you getting me? Otherwise, I'll read the definition. You are able to understand in the better. Read the definition. I will read the definition. It is a matrix obtained by removing the row corresponding to the reference node. Now look at it. In this case, this is the figure. This is the row related to the D node. If I have taken this D as a reference, if I will put only these elements in the matrix, then this matrix is known as a reduced incidence matrix. Reduced incidence matrix. Is it right? In this case, always this is A4. This 4 indicates 4 nodes we have is 4 rows we have. Same indication is there in the incidence matrix also. Even though we are observing here 1, 2, and 3 rows, it does not mean it has 3 nodes, but it is A4 means it has 4 nodes, but one of the row is deleted from the incidence matrix. That's why this matrix is known as a reduced incidence matrix. Simple. Nothing complicated. And it is not necessary always to be only this row will be deleted. सिर्फ यही row delete करना है जरूरी नहीं है. Because in that case, our A node may be reference, B node may be reference, or C node may be reference, or D node may be reference. If A is reference, remove this row. If B is reference, remove this row. If C is reference, remove this node. And if the D is reference, remove the last row. Is it right? Means in this reduced incidence matrix, we are deleting the entries of the node which is taken as the reference node or ground node or bottom node. Is it right? And that matrix is known as the reduced incidence matrix. It is known as reduced incidence matrix. And sometimes here, if reduced incidence matrix is given to us, we can obtain the incidence matrix also. How it is, that I am trying to discuss. अगर हमें reduced incidence matrix दिया है तो भी हम original matrix निकाल सकते हैं. कैसे? Now look at it. Here it is A4 and we have the 3 rows. Means this is reduced incidence matrix. I don't know which row is deleted. Still I can find out the 4th row. How it is? Look at what is the philosophy or what is the basic property of this basic property of the incidence matrix. Summation of each column is 0. But this thing is not applicable to the reduced incidence matrix. Reduced incidence matrix में ऐसे नहीं होता. Is it right? This is -1 means यहाँ पे एक entry होना चाहिए which is of the +1. यहाँ पे -1 है means यहाँ पे एक entry होना चाहिए +1. Here is -1 means here will be the entry of the +1. Here is -1 is there, +1 is there. That's why its entry will be 0. Here is +1 and -1 means entry will be 0. Here is again +1 and -1 means its entry will be 0. Its entry will be 0. This is right. And this row we can obtain +1, +1, +1, 0, 0, 0. This means if from the reduced incidence matrix also we can obtain the original matrix. Original incidence matrix. Look at here. What are the entries? This is +1, +1, +1. This is 0, 0, 0. How we have obtained that? अगर ये डिलीट हुआ है तो भी हम इसको ओपन कर सकते हैं, बिकॉज इसके समेशन 0 होने के लिए दिस इज -1 देन इट शुड बी +1, दिस इज -1 देन इट शुड बी +1, दिस इज -1 देन इट शुड बी +1. Here +1 is there, -1 is there, means its entry 0. This +1 is there, -1 is there, its entry will be 0. This is +1 and this is -1, means its entry will be 0. And this is the way of obtaining reduced incidence matrix and original matrix from the reduced incidence matrix. Means we can do vice versa. If the incidence matrix is given to us, we can obtain its reduced incidence matrix, and if the reduced incidence matrix is given to us, we can obtain its original incidence matrix. These are the things about the incidence matrix. What is the statement? For incidence matrix shown below, it is not the reduced incidence matrix, it is the original incidence matrix. For the incidence matrix shown below, draw the related graph. Means here in this case we want to draw the related graph. I will discuss that particular point. Is it right? Now here how many rows we have? 1, 2, 3, 4 rows we have. Means in this particular case, this is A, this is B, this is C, and this may be the D. We have the 4 nodes. How many branches we have? This is first branch, this is the second branch, this is the third branch, this may be the fourth, this may be the fifth, and this may be this is fifth, and this may be the sixth. Means in this particular case, we have the 4 nodes and 6 branches. What I will do? I will draw the 4 nodes and 6 branches. These are the 4 nodes. This is node A, this may be the node B, this may be the node C, and this may be the node D. Is it right? So here, from this given incidence matrix, we are planning to draw its graph. Is it right? For node A, what we have? For node A and B, we have 1 point. This is for node A and B, we have 1 branch. It is plus for 1, means outgoing for A node and incoming for B node, means outgoing from A, incoming for B, its direction will be something like this. The branch number 2 is connected between B and C. This is B and C. Branch number 2, this is the branch number 1, this is the branch number 2 is connected between these 2 nodes. And how is the direction? It is plus for B and minus for C. Means it is outgoing from the B and it is incoming towards the C. Incoming towards the C. Means its direction will be something like this. Is it right? For third branch, this third branch is connected between the B and D. This is B and D. It is connected between the B and D. This branch is connected between the B and D. This is the branch number 3rd. How is its direction? Plus from the B and minus towards A. Means it is outgoing from the B and it is coming towards the D point. Is it right? Branch number 4 is connected between the C and D. This branch number 4 is connected between the C and D. This is the branch number 4. How is this connection? It is plus from D, means it is outgoing from the D, and minus for C, means it is incoming towards the C. That is the direction. For branch number 5, it is connected between the A and D. This is A and D. This is A and D. Between these 2 points, this branch number 5 is connected. This is the branch number 5. How is this direction? Plus 1 from the A, means it is outgoing from the A, and incoming, this is minus, this is 5th one. This is A and this is minus 1 towards D, means it is incoming towards the D. And finally the branch number 6 is connected between the node A and C. It is connected between the nodes A and C. Means we are connecting between the nodes A and C. How is the direction? It is minus 1 for the node A and plus 1 for the node C. Means it is going from the node C towards the node A. Means this is the obtaining the graph from the given incidence matrix. Now what is the case here? Draw the corresponding graph for the reduced incidence matrix shown below. This given matrix is the reduced incidence matrix A. Is it right? First we have to obtain its normal matrix. Because we have deleted one row. First we have to add that row. Is it right? How will be the case? This is 1, 0, 0, 0. This is available. That is the case 1, 0, 0. Here, then we have, this is 1, minus 1, 0, 0. This is 0, 1, 0, 0. Is it right? Third. Then this is 0, 1, minus 1, 0. This is 0, 0, 1, 0. Then it is again 0, 0, 1 and minus 1. It is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Means here another, there is one column is there. I will write here 0, 0, 0 and 1. Means this much is the complete matrix. Is it right? Then we have to prepare its last row. What is the property of the incidence matrix? Property of the incidence matrix is that summation of each column is 0. Here the summation is not 0, that's why here should be minus 1. Here it is 0, that's why it is already summation is 0, that's why it is 0. Here it should be minus 1. Here it should be 0. Here it should be minus 1. Here summation is already 0. Then here it should be minus 1. Are you getting me? How to prepare this last row for this reduced incidence matrix? Because this is the reduced incidence matrix, means already we have deleted one row, and what row we have deleted, just that I am adding that. Because we should need this particular matrix to draw its graph. Are you getting me? Here it is a plus 1 and this is minus 1. That's why summation is 0. It is plus 1 minus 1, already summation is 0. That's why here will be 0. It is a plus 1 minus 1 and so on. And if we have this matrix, it is A node, B node, C node, D node and E node. We have 5 nodes. This is one branch, second branch, third branch. This is the fourth one. This is the fifth branch. This is the sixth. And finally it is the 7th branch. Means we have the 5 nodes and 7 branches. I will draw that particular part of the figure here. This is one node, second node, maybe third node, this is fourth node, and this may be the 5th node. Draw any shape. Here this is A node, this may be the B, this will be the C, this is D, and finally it will be the E node. That I have taken. Then for branch number 1, it is connected between the A and E. This is A and E. Here is a branch number 1. How is the direction? It is outgoing from the A. This is direction will be something like this we have carried out for this. Branch number 2 is connected between A and B. This branch number 2 is connected between the A and B. This is branch number 1. This is branch number 2. It is outgoing from the A because plus for A node and minus for this B node means outgoing from the A node. We have done for this. Branch number 3 is connected between the B and E. This is connected between the B and E. Means something like this. This is the branch number 3. How is the direction? It is outgoing from the B. It is outgoing from the B. We have done for this. This is the branch number 3. How is about branch number 4? Branch number 4 is connected between the B and C. This is B and C. It is the branch number 4 is connected between the B and C. Is it right? It is outgoing from the B and incoming towards the C node. Finally, between the C and E, we have one branch, C and E. This is C and E. We have one branch is connected between the C and E. This is the branch. This is the branch number, I guess, 3. Already 1, 2, 3. This is the branch number 4 between the B and C. B and C, branch number 4, branch number 5, C and E. This is C and E, branch number 5, and it is outgoing from the C. It is outgoing from the C. This is the branch number 5. Is it right? Branch number 6 is connected between the C and D. C and D. This is CD. Branch number 6 is connected between the CD, and it is outgoing from the C, incoming towards the D. Outgoing from the C, incoming towards the D. And finally, D and E. We have one branch. It is connected between the D and E. It is something like this. It is connected between the D and E. In this case, it is outgoing from the D and incoming towards E. Incoming towards E means it will be something like this. Now count the number of branches. This is 4, 5. This C and D. This is C and D. This is the branch number 6 and this is the branch number 7. Now look at it is 1, 2, 3, 4, 5, 6 and 7. This is the graph for this particular given matrix. In this way, if the reduced incidence matrix is given, we can prepare its incidence matrix, and from this incidence matrix we can prepare its graph. That is the philosophy how to prepare the graph from given incidence matrix or from the given reduced incidence matrix.